Should be all good, guys. We're doing A-Level Maths Paper 2 predicted topics on YouTube. A-Level Maths Paper 2 predicted topics on YouTube. We're going to be going over hard questions, challenging questions that haven't came up yet. We're going to be going over it on YouTube, guys. A-Level Maths Paper 2 predicted topics. Things that we didn't see in Paper 1 that we're likely to see in Paper 2. I'm going to be going over some hard questions. So today we're going to be looking at some modulus, some binomial expansion, a bit of these connected rates of change, some parametric differentiation, and a bit of implicit differentiation. Okay, guys? Definitely hard questions. I hope chemistry went well. I hope maths went well. I appreciate the likes. Have you seen the AQA? I do OCRA. I focus on OCR chemistry. I don't really focus on AQA. If people on YouTube give me a thumbs up if you can see everything. I'm going to start in just a couple minutes, just while a few people join. Definitely waiting for Pax as well. I know Pax wants these hard questions. I'm going to leave up on the stream, guys, all of the predicted topics that we would expect to come up in paper 2. Because we are on live on YouTube. Let me know how you guys found chemistry paper 1 or A-Level Maths paper 1. But we have a good feeling we know what's coming up in paper 2. And the structure to 2022 is so similar. Fred is back, Fred is back, Fred. I apologize for doing past paper questions yesterday. We're going to be doing stuff not from past papers, either from international papers or from Madas. There's no point in doing questions you guys have already done before, just because it was so similar to 2022. OCR Chem was good, yeah? That's good to hear, that's good to hear. Easier than last year. That's great. The grade boundaries might be high, but if you feel good, that's all that matters. This is for Edexcel Maths, guys. Edexcel Maths, okay? Edexcel Maths paper 2. Of course, most of the topics are relevant, and it will be useful either way. We'll start in just a few minutes, guys. I'm just going to make sure the stream is all good and not like crashing or anything. Looks like we're all good. Looks like we're all good. Well, guys, we're going to start in just a few minutes. Let me know if you guys have any questions for A-Level Maths Paper 2 or OCR. AQA Chem was good. I'm seeing people were quite happy with the Chem this year. Hopefully the grade boundaries won't be too high. You have to remember, the people who did well tend to be more vocal, so I wouldn't get too stressed if you only hear people say they're doing well. I don't think the grade boundaries can be that high. As long as you feel confident, you should be fine. Guys, trig modeling, geometric sequences, we see these come up every single year. Same as binomial expansion. I've got a pretty hard binomial expansion question today. It is a Madas question, but it's one of those where you have to get an approximation in part B using your answer to part A. Definitely a good question. We're gonna start in just a couple minutes, guys. Definitely waiting for Pax. I want to see Pax in. Are the Edexcel questions similar to AQA? They are similar. We cover very, very similar topics. Yeah, I believe the topics are almost identical. You know, after every year after A-levels, everyone says it's easy. Yeah, the people who come out, the people who are the loudest, they always say the topics were easy, the paper was easy. Okay, so I wouldn't get too stressed. I would not get stressed about what other people are saying. It's all about how you feel. And remember, the people who aren't vocal are the ones who did badly. So do not think just because TikTok is saying, "Oh, that was so easy," that the grade boundaries change. People do it every year. Maybe they'll be slightly higher. Maybe they'll be slightly lower. It's the same thing every year. Guys, do give me a thumbs up or ask any more questions. We're gonna start in 2 minutes, I reckon. 2 minutes. Just making sure that the stream's not crashing or anything like that. Looks like we're all good. So guys, we are doing predicted topics for paper 2. We are doing predicted topics for paper 2. I'm gonna leave the first question up, guys. If you guys want to have a go yourself. Yeah, this live stream will be on YouTube afterwards. You can rewatch it if you want. It will be all on YouTube, all on YouTube. If you click the live section on YouTube, you'll see all my past live streams. I would say today and tomorrow are definitely going to be the most helpful because these are, we think, the exact questions that are going to come up in the paper. So I'm just leaving this functions question up, guys. Modulus question. Definitely a good question. A lot of key things that didn't come up in paper 1. Just going to go for 1 more minute, guys. I'm going to get started, all right? Could you go over when we don't just solve for both positive and negative? That's exactly that. In this modulus question, it's not going to be just positive and negative solving. You have to be careful about modulus function that they give you and where your graphs will intersect. We are going to cover that kind of harder, not just obvious part of your modulus question, okay? There will be one aspect of this, which is just the positive and negative solving. We are also going to look at that harder aspect. How long will I be live? We've got 5 questions, 5 tricky questions, so it's going to take me a while to go through them. I don't know how long it's going to take, but we're going to do those 5 questions. Need them to be low, need the grade boundaries to be low. And we'll see. It could be low, it could be high. Okay, guys, 1 more minute. Just making sure the stream's all good and not crashing. So I'm waiting for Pax to be here, but it looks like Pax is not here today. Bit of a shame, but it's alright. Alright guys, I think we're gonna get started now. For anyone on TikTok, we are live on YouTube. Link in bio. Alright guys, let's get started. Let's start going through these questions. So, I'll read the question out, guys. The functions f and g are defined as f of x equals the modulus of a minus 2x plus a. X has to be a real number. And then for g of x, we have the modulus of 3x plus a, where x must be a real number, where a is a positive constant. Okay? Part A, nothing too tricky. This should be very quick in the exam. We have to sketch in the same set of axes the graph of f of x and the graph of g of x. The sketch must include the coordinates of any points where the graphs meet the coordinate axis. Alright guys, so when we're sketching our modulus graphs, we're going to want to focus on just the thing inside our modulus first, okay? So sketching our f of x, guys, let's just focus on that a minus 2x. All we're doing, guys, step by step, we draw out the line of a minus 2x, okay? So remember, this will have a y-intercept of a gradient of minus 2, and setting y equal to 0 will intersect the x-axis at, so we set y equals to 0, add over the 2x, divide by 2, we intersect the x-axis at a over 2. Then applying that modulus function, so before we were just drawing the line, now applying the modulus function, we know the modulus function means we can't achieve negative y values. We reflect it in the x-axis. So last part of sketching the graph, we add a. So we're adding a to every single y value. So the whole graph will be shifted up by a. So our y-intercept will become 2a, and then where we would have intersected the x-axis, that coordinate where the vertex is will now be a over 2a, because we added a to that 0. Then sketching g of x, we're just doing this one by one, guys. G of x is just the modulus of 3x plus a. Same idea, we're going to draw out the line of 3x plus a. So our y-intercept will be at a, and our gradient will be 3. So absolute same idea, we would draw that line out. It would have y-intercept a, and it would have x-intercept minus a over 3. Same idea, we set that y equals to 0. Remember guys, when setting y equals to 0, the modulus of 0 is just 0. So you don't have to stress about the modulus thing when setting something equal to 0. That's not just for this question, that's just in general. So we would take away the a, divide by 3, so our x-axis intercept will be a minus a over 3. Then once again, then we apply that modulus function. We cannot get negative y values, so we reflect in the x-axis. So now guys, just put it all on the same axes. I just wanted to go one by one, putting it all on the same axes. We have f of x, which has vertex at a over 2a, and a y-intercept at 2a. Then g of x, which crosses the y-axis. Sorry, has a y-intercept at a, and then we cross the x-axis at minus a over 3. And the key thing I wanted to point out, guys, for part B, so this is obviously a rough sketch. It doesn't need to be perfect, but we can see that our function g of x is steeper than f of x. That'll be quite important when thinking about where they intersect, okay? So going up to part B, guys, for part B, we have to determine, in terms of A, the coordinates of any points of intersection between the two graphs, okay? So guys, you have to be really, really careful here. We're obviously going to be using our answer to part A, because we can quickly see there's obviously a visible intersection as we see here, guys, okay? We can see the visible intersection. And we can see, just going down, guys, this will be the reflected branch of g of x, he says. Yeah, so sorry guys, we have the clear visible one, which will be when g of x has that gradient of 3, and when f of x has that gradient of minus 2. We can see these would just be the positive branches of each, right guys? Because, I'll say it again, f of x has that gradient of minus 2, and g of x has that gradient of 3, and that is the visible intersection. So these are not the reflected branches of either, these were just the original lines, so the positive branches. So as I say here, we're going to have 2 points of intersection, guys. The first one is that clear visible one. Now here's the point, or the key idea, of drawing g of x steeper. Because g of x is steeper than f of x, we can see eventually that f of x line will intersect that steeper g of x line. It will be at quite a negative x value, but we can see they would eventually intersect. So we have to consider the intersection of those two. So in this case, we don't actually have to consider that reflected branch of f of x. We're only considering the positive branch of f of x. When I say positive branch, guys, all I'm saying is we leave this a minus 2x as it is. However, for g of x, we have to consider both that positive branch, where we have this gradient 3x, the visible intersection, but we also have to consider that minus 3x minus a. This branch that we have here, that would eventually intersect with that branch of f of x. So in this case, we're not doing minus, minus, positive, positive. We're only thinking about the positive branch of f of x, but we have to do both the reflected and the positive branch of g of x when considering the 2 points of intersection. So let's go through it, guys. So for that visible intersection, taking those positive branches, it's just the terminology I use. It doesn't matter how you say it. Taking the positive branches, we have a minus 2x, exactly what we had, plus a equal to 3x plus a. From here, we can simply add over the 2x to the right. Then we have a plus a on the left, that's 2a. Take away the a from the right onto the left. So we're going to be left with a equals 5x. So our x value for that first intersection will be a over 5. Now, in order to find the y, because we're trying to find the coordinates, in order to try to find the y, we plug in this x value into either one of these equations, it doesn't matter. So plugging in x equals a over 5, let's plug it into 3x plus a, just looks a bit easier. So we have 3 times a over 5, that's 3a over 5, plus a, or 5a over 5, we get 8 over 5a. So our coordinates, our first point of intersection, which is the visible point on this graph, okay, will be the visible point of this graph, will be at a over 5, 8 over 5a. Okay? Sorry guys, but I think my stream's all good. Just got a notification from OBS. I think we're all good. Okay, I'll carry on. So once again, guys, we maintain that positive branch of f of x. However, this time we're going to have the reflected branch of g of x. So this time for our g of x, we're going to have to take minus 3x minus a and set that equal to a minus 2x plus a. This is a good example where you can't just do reflected reflected and positive positive. You have to be careful in these questions. So we have a minus 2x plus a, just the same as f of x as before, and that intersects with minus 3x minus a. So all we're going to do, add over the 3x to the left-hand side to get x. We take away a, take away another a, so that's minus a, minus a, minus a, minus 3a. So that x equals minus 3a. Now to find the y coordinate, same things before, we can plug it into either one. I'm going to plug it into this minus 3x minus a, just looks a little bit easier. So plugging in minus 3a, we have minus 3 times minus 3a, that's 9a. Take away a, we have 8a. So our coordinate for the other point of intersection that we don't see on the graph is minus 3a, 8a. Now moving on to part C, guys, I'm going through the whole question first, and then I'm going to answer any questions if you have any. So for part C, we have to find the simplified expression for g of f of x, okay? So g of f of x, composite function, all we're doing is plugging in our function f into g. Nothing scary. Nothing scary at all for this one. We have to simplify it a bit. That can be a little bit, I'm going to tell you guys a very key point when looking at modulus functions. So we're going to have, plugging f into g, 3 times the modulus of a minus 2x plus a, and then the modulus of all of that, okay? So let's just go through it. So going through it, just simply plugging in f of x into g, we have exactly as I said, the whole thing is a modulus of 3 times a minus 2x plus a, okay? But here's the key thing we have to realize, guys. We can actually get rid of that modulus sign, I guess, from this whole function, okay? The reason for this is, so we know that a is a positive constant. I'll scroll up back up to the question, guys. They give all this information for a reason. So we know a is a positive constant, okay? So going back down, sorry guys, my hay fever is killing me. Okay, so because a is a positive constant, let's think of it like this. We have something in this modulus which could get negative because of the x's, but because it's a modulus, we know it must be larger than or equal to 0. Then we add a, that's positive, so we have something that must be positive, plus a, which is positive, times by 3, so we're still positive, plus a, even more positive. So the modulus of all of that, there's no need to put a modulus sign, because we know the whole thing is going to be positive. So therefore, we can remove the outer modulus sign. As exactly as I've said, because we know the modulus of a minus 2x plus a is larger than or equal to 0, and using the fact that a is a positive constant, we can ignore that modulus on the outside. So to expand this, guys, and simplify it, treat the modulus, whenever you see this in exam, treat this as a single term. So when we expand out these brackets here, we do 3 times the modulus of a minus 2x, and we also do 3 times a. And then obviously we're adding a. So exactly just expanding it out like that, guys, we have 3 times the modulus of a minus 2x plus 3 times a plus a. 3a plus a is just 4a. So we have 3 times the modulus of a minus 2x plus 4a, and we can't really do anything more from there. So that is our function, fully simplified, g f of x. So last part of this question, guys, part D. This is the part which I know is easy for you guys, but you gotta do it, you gotta practice it. We have to solve in terms of the equation g f of x, which we just found, being equal to 10a. So this is where we have to find the positive and the negative branch and just solve. I know this bit's easy, I know it's not very helpful, but we've got to do it. So part D, guys, exactly as I said, first thing we want to do in general with modulus functions is if we can, when solving equations, we do want to isolate that modulus function if we can. So we're going to take away that 4a from the right-hand side to get 3 times the modulus of a minus 2x equal to 6a. Then we're going to divide over by 3, so we have the modulus of a minus 2x equals 2a. And then here we take the positive and negative branch. So we set a minus 2x equal to 2a, and then we set minus a plus 2x equal to 2a. So just solving those two, bit of GCSE stuff, guys. A minus 2x equal to 2a. Sorry, guys, it's glitching a bit. There we go. A minus 2x equal to 2a. We're going to take away a from the right hand side. We have minus 2x equal to a, divide by minus 2. So one of our x coordinates will be minus a over 2. Then setting minus a plus 2x equal to 2a. Bit of rearranging again, add over the a, divide by 2. We get x equals 3 over 2a. So our two solutions will be x equals minus a over 2 or x equals 3 over 2a. And that's it. Let me know if you guys have any questions about that modulus or any. Just let me know, guys. The chat is a bit delayed for me, so I can't really see. Sorry if you guys have already responded. Give me a thumbs up if you want me to move on, or I'm just gonna tilt my laptop quietly, slightly up, guys, just because it's burning already. Okay. Let me know, guys. Let me know if you have any questions or you want me to move on. We'll put on the next question is binomial expansion if you guys are happy. But let me know, let me know. Rin seems happy. Fred wants part C. I got you, Fred. So part C again, all we were doing was finding the composite function. Oh, Pax is here. Great to hear. We were just finding the composite function. All we're doing is plugging in our function f into our function g. Okay? So we know our function f is the modulus of a minus 2x plus a, and g of x, so g of some input, is 3 times x plus a. So all we're doing is instead of plugging in x, we plug in everything in f, this modulus of a minus 2x plus a. So going down to part C, once we plug it in, because we established that everything inside was positive, because a is positive, and everything in our modulus has to be positive, we can ignore that modulus sign on the outside. Because we know everything inside must be a positive number, we can ignore it. That's why they give you this information of a being a positive constant. From there, when we expand out these brackets, we treat the modulus of a minus 2x as one term, and then obviously we just expand with 3 times a to be 3a. But I guess the tricky part there is treating a minus 2x as one term. Some people might not see that. And then just doing 3a plus a, we get 4a. That was quite brief, but I know we have a lot of thumbs up, so I'm going to carry on to the binomial expansion question. I'm going to leave it up just for a second, guys, if you want to have a go. If not, just give me a thumbs up or say all good to go. Is there any case where you wouldn't ignore it? I mean, if we didn't know that the number inside would always be positive, then we couldn't ignore it. This is actually more of an exception. The fact that we know everything inside must be positive means we can ignore it. So I guess that's kind of the trick, and that's also why they mention a as a positive constant. Yes, it also helps to draw out the graph, but then when getting to that question, you can reuse that piece of information. They do tell you things for a reason, so you always have to be careful when approaching every question and looking back at what they tell you. So always be very careful with those things. But yeah, if you could achieve a negative value, then you definitely would have to include that modulus sign because it is part of the function. Alright guys, let me know if you want me to start working through it or if you guys want a minute just to kind of read the question, have a go. I'll just wait for any thumbs up if you guys want me to move on. I saw Pax is happy, Music Anytime happy, Rin happy, Fred happy. Let me know guys, let me know. This is definitely a very key topic that I don't want to say definitely, but is definitely going to come up in paper 2. It could be an easy question, but it could be a hard one like this. So I'd definitely say be comfortable with this kind of question. Because we are live on YouTube for paper 2 predicted topics. Okay, Fred's happy, so we're going to move on, guys. Fred's happy, I'm happy. So guys, we're given that f of x equals the square root of 4 minus x over 4 plus x, where naturally the modulus of x must be less than 4. That's just the condition. We have to expand f of x as an infinite convergent series up to and including the term in x squared. So it's actually not too bad. We're going up to x squared. You always get annoyed in exams when you see x cubed or even x to the 4. Don't think we've seen that yet. But up to x squared, nothing too scary. So in these binomial expansion questions, we want to rewrite what we have, especially within the square root, as something in the brackets to the power of something. So let's go down. So first thing we're going to want to do, guys, rule of sets. We have this whole square root of 4 minus x over 4 plus x. We can split this up as a square root of 4 minus x over the square root of 4 plus x. We know the square root of something is the same as writing that thing to the power of a half. So we can rewrite this as 4 minus x to the power of a half multiplied by 4 plus x to the power of minus a half. Remember, it's a negative power, it brings it up to the numerator. So we write it like this, guys. Now recall, when we have negative or fractional indices, we can use that binomial expansion formula that they give us in the formula book. You don't have to memorize it, it's in the formula sheet, just use the formula sheet in this case. I know people say you shouldn't use it, but in this case, just use it, okay? But guys, remember, in order to use the formula in the formula book, we have to have it in the form of 1 plus ax, where a is some constant, to the power of n. But right now, we currently have it as 4. Well, we have it as 4, but we need 1. So we need to get rid of these 4s in both brackets. So to get rid of the 4, guys, we're going to factor out 4 to the power of a half. Maybe it might be best to think of it as factoring out the 4 within the brackets first, and then to take that 4 out of the brackets to the power of a half, or minus a half, then take out 4 to the power of a half, and 4 to the power of minus a half. Okay? So dividing what we have inside the brackets by 4, we get that 1. So we have 1 minus a quarter x to the power of a half, multiplied by 1 plus a quarter x to the power of minus a half. So we simply factor out that 4, and we put it to whatever power was on our brackets. So we have 4 to the half, and 4 to the minus a half. But we can see 4 to the half multiplied by 4 to the minus a half, that's just 1. So we can ignore both of these 4s. They do make these questions on purpose, guys. They don't want you to be left with 4 to the half and 4 to the minus a half, and then have to play around with that. So from here, guys, we have 4 minus a quarter x to the half multiplied by 1 plus a quarter x to the power of minus a half. Here we can use our binomial expansion formula. Our n value, so the power, is a half for this first bracket, minus a half for the second, and our x value is minus a quarter x for the first bracket, and plus or just a quarter x for the second bracket. I'm not going to waste your time, guys. Plug it into the formula, okay? Only up to the x squared term, thank God, otherwise it would be a very, very long question. We have 1 plus nx, n is a half, x is minus a quarter x, plus n times n minus 1 over 2 factorial, then we have x squared. The one thing I do want to mention, guys, is with this x squared and x cubed, everything that's in your x must be squared and everything must be cubed. Well, in this case, it's just squared, but everything must be inside of that. So that minus a quarter x must go inside. It's not minus a quarter times x squared, it's minus a quarter x all squared. Just the key thing to think about and remember to do in the exam, a very easy way to make silly mistakes, okay? So guys, just plug it in your calculator. Once again, I'm not going to waste your time with this question. Plug in your calculator, be very careful when plugging in your calculator, especially with negative and positive signs. Sometimes my calculator gives me the wrong signs, which is not ideal. So just putting in the calc, we have 1 minus an eighth x minus 1 over 128 x squared. Then we have 1 minus an eighth x plus 3 over 128 x squared. So we're going to have to expand this out, guys. But remember, we only need up to the x squared term. So we're going to do 1 times 1, 1 times 1 times minus an eighth x, 1 times 3 over 128 x squared. Then we're going to do minus an eighth x multiplied by 1 and minus an eighth x. We're not going to multiply our minus an eighth x or minus 1 over 8x by 3 over 128 x squared, because this would give us x cubed. We don't want x cubed, we want only x squared. And same idea with this minus 1 over 128 x squared. We only multiply that by 1, because anything else would give us x cubed and then x to the 4, which we do not want in this question. So expanding out, guys, exactly as I said before, doing 1 times everything in the right-hand bracket. Just rewrite the right-hand bracket, 1 minus an eighth x plus 3 over 128 x cubed, minus an eighth x times by 1, minus an eighth x, minus an eighth x multiplied by minus an eighth x is plus 1 over 64 x squared, and then just doing minus 1 over 128 x squared by 1, just minus 1 over 128 x squared. Now we add them all together, 1 plus 0 is just 1, minus an eighth x, minus an eighth x, that's minus a quarter x, then doing 3 over 128 x squared plus 1 over 64 x squared minus 1 over 128 x squared. That would be 4 over 128 or 1 over 32 x squared. That's your final answer to part A, guys. You know, this would be a pretty horrible question. You have to be very careful not to make silly mistakes. To be honest, this will probably be a question which guarantees no one to get full marks just because so many people make silly mistakes putting this into their calculator. So I'll be very, very careful with these questions. But part B, guys, part B is the more interesting part. By subbing in x equals 0.5 into the expansion of part A, we have to show that root 7 is approximately 339 over 128. Okay, so we're using our binomial expansion to part A. Remember, guys, error carried forward. They won't kill you if you got the wrong expansion for part A. You'll still be able to get some marks. So moving on, guys, plugging in that x equals 0.5 into the left, into the right. So we have 4 minus 0.5, 3.5, or 7 over 2. And 4 plus 0.5, 4.5, or 9 over 2. Okay, this is going to be key. The reason why I'm saying it 7 over 2, 9 over 2 might make it easier to spot our approximation for root 7. Then just plugging in x equals 0.5 on the right, put it in your calc. So we have the square root of 3.5 over 4.5 is approximately, using our binomial approximation, 1 minus an eighth plus 1 over 128. Now rewriting as 7 over 2 over 9, 7 over 2 all over 9 over 2, approximately equal to, like I said, plug it in the calc, this gives you 113 over 128. Currently, we're not quite at our answer. Yeah? Our answer needs to be 339 over 128, and we just need root 7. But the one thing you guys can quickly spot is by writing out as fractions, or even with the 3.5 and 4.5, this is the same as writing 7 over 9. Okay? And the same idea as part A. We can split this up as root 7 over root 9. So splitting this up as root 7 over root 9, well, we know the square root of 9 is 3. We have root 7 over 3 is approximately 113 over 128. But we just want root 7. So all we have to do is multiply that approximation by 3 to just get the approximation for root 7. So we have the root 7 is approximately 339 over 128, exactly as required. Definitely not the easiest. Some people will definitely miss that out, but don't get intimidated. All you have to do is a little bit of manipulation with your answer to part A. I did do a underestimate overestimate last time, but I will say with these overestimate and underestimate questions, it tends to be that because your approximation will only be up to x squared or x cubed, if you were to continue writing out more terms and they ask an over or underestimate, the rest of the terms tend to all be positive or all be negative. So if the rest of the terms would all be positive, your number would keep on increasing as you make your approximation more accurate. But if the rest of the terms would continue to be negative, your approximation will be decreasing as you make it more accurate. So you could currently say, if the rest of the terms are positive that you haven't included in your approximation, you could currently say that you have an underestimate, but if the rest of the terms would be negative, you'd currently have an overestimate, because you'd keep on taking away a little bit more to get that estimate using your binomial approximation. I hope that makes sense, but that's what we saw in 2022. Sometimes it can be annoying to write out a few more terms, but that's about it. Let me know if you guys have any questions about this or if you want me to move on. We have a parametric, oh no, we have a connected rates of change and differential equation coming up next. I wouldn't say it's the hardest one. I definitely have a harder question coming tomorrow, but definitely good practice. Should always revise maths. Maths is the most important subject. Maths and chemistry. I'm a little bit biased. So let me know if you guys are happy. This is my document. Give me a thumbs up if we're all happy to keep on going. Give me a thumbs up if we're all happy to keep on going. Is it? Oh no, no, this document isn't in my bio yet. Okay, I'm happy the overestimate underestimate thing makes sense. I haven't seen one where it isn't all negative terms or all more positive terms. It tends to be all negative or all positive. So that's normally why they ask that question. Is they like to repeat questions, they like to repeat the same ideas. Okay, guys? As we saw this year. I'm seeing thumbs up, I'm seeing thumbs up. Alright, I'm gonna put on the next question, guys. This is from an international paper. Yeah, plenty of thumbs up. Okay, perfect. Right, guys, here's the next question. Connected rates of change and differential equation. Yeah, I will upload this document after into my bio if you guys want to relook at anything. I'll make all these questions publicly available. But this is from an international paper, Edexcel international paper. But not all of that spec is relevant to our A-level spec, so you have to be a bit careful. It's a bit different. Alright, I'll leave this up just for a second, guys. I'll leave it up for 30 seconds. Have a sip of water, let you guys read it. I'm gonna go through it. I will say, guys, this question is almost guaranteed to come up. Differential equations, it's coming up, guys. Hopefully, it's one of those harder questions. Because I would say once you've got this on lock, you'll be able to answer any question. Should normally involve partial fractions. I would not be surprised if it's a partial fraction for part A, and then you do the differential equations for the rest of the question. That's probably what we're going to see. Everyone's happy. I'm seeing loads of thumbs up. All right, guys. Yeah, this will be on my YouTube channel. It's under the live section. You can see all my past live streams. Just gonna give it 10 more seconds, guys. 10 more seconds, and then we're gonna go through this. If any of you had chemistry, I hope it went well. I will be doing loads of organic, guys. Organic is you gotta get 100% for that A star. Let's be honest. So I'm gonna make sure that happens. I'll do a cram course for the whole module 4, whole module 6. OCR though, OCR. All right, guys. So we're told Figure 4 shows a cylindrical tank. Yeah. Figure 4 shows a cylindrical tank that contains some water. They give us this beautiful image here. We're told the tank has an internal diameter of 8 meters and an internal height of 4.2 meters. So simply what we see here. Sorry, I was reading the chat. I did not do the international papers. I didn't do any of them, to be honest. Only if when other people had uploaded them or told me the question about them. So I wouldn't stress too much about not having done these. They're very similar and many of them are easier. We're told the tank has an internal diameter, of 8 meters. Therefore, the radius will be 4 meters and it has an internal height of 4.2 meters. We're told that water is flowing into the tank at a constant rate of 0.6 pi meters cubed a minute. Meters cubed a minute. That's a change in volume, you have a change in time. I'm immediately thinking dV dt. Immediately, guys. There's a tap at point T at the bottom of the tank. We're told at time T minutes, time in minutes, very important in these questions. They love to mix that up. So we're told at time T minutes, after the tap has been opened, the depth of water is H meters. Meters, guys. The water is leaving the tank at a rate of 0.15 pi H meters cubed per minute. Okay, so we're getting in some water, we're also losing some water. So our dV dt has some positive aspects and some negative aspects. Good to think about. We have to show that dH dt, so we want dH dt equals 12 minus 3H over 320. First thing we do in this question, guys, always understand the shape, how to calculate the volume of the shape, and use any information that they give you, okay? So we have a cylinder, guys. You have to know how to calculate the volume of a cylinder. Area of the base multiplied by the height. So connected rates change, differential equations. Let's go, guys. We know the volume of the base is pi r squared. So we know that the radius is 4 because the diameter is 8. So we do pi times 4 squared, 16 pi, and we multiply it by the height, okay? The height will be the water. The height of the water is H meters, guys. So we know we're going to have 16 pi H for our volume. So we can now find dV dH. This is great because we know we have dV dH. We also know we have dV dt. We're going to be able to do that multiplication to find dH dt. Let's go step by step. So dV dH is going to be left with that constant of 16 pi. We're told the water enters at 0.6 pi meters cubed per minute, and the water goes out at 0.15 pi H meters cubed a minute. So our dV dt will be plus 0.6 pi minus 0.15 pi H. Classic question, guys. You would definitely see this. So we need dH dt. What we can do is do dH dV multiplied by dV dt. To find dH dV, all we have to do is do the reciprocal of dV dH. Okay? So we found the volume to be pi r squared times by the height. Differentiated it, we got dV dH. We want dH dV so we can get dH dt. dH dV, find the reciprocal, it's just going to be 1 over 16 pi. So multiplying the two together, as you can see, I forgot to write in the pi here, so I got creative. We have 1 over 16 pi multiplied by 0.6 pi minus 0.15 pi h. Remember that 0.6 pi minus 0.15 pi h is our dV dt that they give us in the question. We can quickly see that all these pi's will cancel out on the numerator and the denominator, so we get left with 0.6 minus 0.15 h over 16. Quickly going back up, I'm sure you guys saw it. It's already looking quite similar, but with these questions, especially the show that questions, sometimes the easiest thing to do, in this question it's not too hard, but in general, it's good to compare denominators, because the denominator tends to be a little bit easier compared to the numerator. So what do we have to do to 16 to get 320? We multiply it by 20. So we're going to multiply the top and bottom by 20. Hallelujah, it gets us exactly what we need. 12 minus 3h over 320. That's the answer to the show that. Let's look at part B. Yeah, the volume is area of the base times by the height. And we know the height of the water, as they told us, is h meters. So they tell us that given that the depth of water in the tank is 0.5 meters when the tap is opened, so I'm hearing when the tap is open, yeah, t equals 0, okay? What is it? At time t minutes after the tap has been opened. So if we've just opened the tap, t equals 0. I'll read this question. Anything with initial, in this case when it's opened, h equals 0.5, t equals 0. Okay, so we know that. We're going to obviously be using that in the question. When they give you information, you also know it's going to be a differential equation because we're going to have to use that information to find our constant of integration. Hope that makes sense. They want us to find the time taken for the depth of water in the tank to reach 3.5 meters. So going down, guys, write out what we know. T equals 0, h equals 0.5. Once again, when they give you this information, you know you're going to be using a differential equation. And because it's to show that question, we're going to be using our answer to part A. So differential equation, we want all of those h's on one side, all of the t's on the other. So we're going to divide by 12 minus 3h on the left and multiply over by dt. So we have, integrating both sides, 1 over 12 minus 3h dh, integrating with respect to h, equals the integral of 1 over 320, integrating with respect to t. Integrating the right here, very easy. It's a constant, integrating with respect to t. It's going to be 1 over 320 t. On the left here, we can actually recognize this is in the form where we can use our natural log. Because the top, or the numerator, looks something like the denominator differentiated, if we differentiate that denominator, we're going to get minus 3. 1 minus 3, pretty close. We have something that looks like the denominator differentiated. So it will be minus a third, because to get from minus 3 to 1, we'd have to multiply by minus a third. Natural log of our denominator, 12 minus 3h, equal to 1 over 320t. And of course, guys, plus c. Now remember, these are two infinite integrals, so they would both have constants of integration, but because we can combine them into one constant, we just put that plus c. Normally on the right side, it doesn't particularly matter. So from here, guys, to find that constant of integration, plug in t equals 0, plug in h equals 0.5. T equals 0, everything here, this 1 over 320, we multiply by 0. Then plugging in 0.5 into our 12 minus 3h, it's going to be 12 minus 3 over 2. So we have minus a third, natural log, 21 over 2 equals our constant. So we found our constant of integration. Now we're going to plug this back into this equation over here, okay? So plugging this back into our equation, we have minus a third natural log 12 minus 3h equal to 1 over 320t minus a third natural log 21 over 2. Now remember, guys, back to the question, they wanted us to find t when h equals 3.5, okay? Time taken for the depth of water in the tank to reach 3.5 meters. So we have to plug in h equals 3.5 and then rearrange to find t. I'm not going to waste your time with this one, guys. It would be a lot of calculator stuff. So putting in h equals 3.5, we have minus a third natural log 3 over 2 equals 1 over 320t minus a third natural log 21 over 2. So we're going to add over this a third natural log 21 over 2. Then we're going to multiply over by 320 to just be left with t. Remember, t is in minutes, guys. So that t equals 207.56 minutes. Rounded to three significant figures, we have 208 minutes as our final answer for this connected rates of change question and a bit of differential equations. Definitely something going to come up. I'm going to do a harder one tomorrow and some parametric integration, which has some partial fractions involved. Because when we see these differential equations, they love to do partial fractions with these differential equations. Always using the answer to part A to move on to part B. Let me know if you guys have any questions. I'm going to leave the next question on if you guys want to start having a go at it. Try to get the whole thing in. And let me know if you have any questions about that. I'm going to make sure the stream hasn't blown up yet. Looks like we're all good. The stream has not blown up. My laptop is very hot, guys, so I warn you now, there's always a risk when I'm doing this. This is definitely a good parametric differentiation question. A bit of algebraic manipulation, always useful. Guys, give me a thumbs up if you want me to move on, or if you have any questions, let me know. Let me know if you guys have any questions. Guys, we are live on YouTube, Let me go. Let me know, guys. Let me know if you have any questions, or thumbs up if you want to move on. The chat is very slow for me, so sorry if I'm repeating myself a few times. I hope you guys are feeling good for paper 2. And if you don't feel good about paper 1, you still have paper 2 and 3. I warn you now, guys, I am your man for statistics. This year, I would not recommend, I'm not going to be doing mechanics. My first year doing this, and I know I can be the most useful by doing statistics. In my degree, all my modules are statistics based, and I do want to help you guys as much as possible, so I will be focusing on stats. I'm going to recommend Bison Maths, Neil does Maths if you want to do mechanics, but I'm going to be smashing out statistics. That large data set is going to seem easy once I'm done with it, okay? You wouldn't even be stressing about it. Whatever marks come up, it's going to be easy. All these normal approximations, don't even worry, guys. I'm seeing some thumbs up, I think I'm going to move on, guys. All right, let's go on. Bit of parametric differentiation. We're going to see it in paper 2. Let's not joke around here, guys. We are going to see this topic come up in paper 2. Parametrics are going to come up, okay? So question 8, and this, I believe this is also an international paper. Figure 3 shows a sketch of curve C with parametric equations x equals 6t minus 3 sine 2t and y equals 2 cos t, where t must be larger than or equal to 0 or less than or equal to pi over 2. We're told the curve meets the y-axis at 2 and the x-axis at k, where k is a constant. We have to state the value of k. So part A, nice one marker, nothing too tricky. So we're told it meets the x-axis at k. Well, we know that y equals 0 when we know that y equals 0 when we intersect the x-axis, okay? So all we have to do is find the value of t when y equals 0 and plug that value of t into our x parametric equation. So let's do it. Find the value of t when y equals 0. So we set our y parametric equation of y equals 2 cos t equal to 0. Divide both sides by 2. 0 divided by 2 is just 0. So we have that cos t equals 0. And remember, guys, because our restriction is t must be larger than or equal to 0, less than or equal to pi over 2, t will be pi over 2. Because obviously cos t will be equal to 0 infinitely many times. But we're only going to consider our given range, okay? So t equals pi over 2. Now plugging in that pi over 2 into our x parametric equation to find the coordinate where we intersect the x-axis. We have 6 times pi over 2, that's just 3 pi. Take away 3 times sine of pi over 2 times 2. Because remember we had that 2t. So pi over 2 times 2, that's just sine of pi. Sine of pi, draw the graph, put it in your calc, whatever you want. Sine of pi is just 0. So we're going to have 3 pi minus 3 times 0 is just 0. So we're going to be left with 3 pi. That's part A, quick one marker. Maybe it'll even be 2 marks, who knows? But guaranteed marks, or should be. We have to use now parametric differentiation to show that dy dx equals lambda times cosec t, where lambda is some constant to be found. First thing I'm going to say, guys, do not stress when we see lambda, mu, whatever. It's just some unknown constant, all right? They want it to look scary. Don't be intimidated, okay? So dy dx, parametric equations, guys, it's going to be dy dt over dx dt. You have to know that has to be instant in your mind. So we're going to have to find dx dt and dy dt in order to find dy dx. So we know that y equals 2 cos t. Differentiating cos, we get a minus sine. So that's going to be minus 2 sine t. Nothing scary for dy dt. Looking at dx dt, 6t. Differentiate it will just be 6, get rid of that t. Then that minus 3 sine 2t. We know that minus sine differentiates to minus cos. Remember, this is chain rule because we have that 2t within our sine function. So we have to multiply by that 2t differentiated. So we're going to have minus 6 cos 2t. So we have dx dt and we have dy dt. Guys, we're live on YouTube if you want to see the questions. So we have dy dt over dx dt. Putting it all together, we have minus 2 sine t over 6 minus 6 cos 2t. Now, first thing I'm thinking, guys, in our answer, we had cosec t. So there's 2 things I'm immediately thinking. Cosec t, look at that third letter, that's 1 over sine. So the fact we have cos is already terrifying me. Second thing, we know that we only want individual t's. We don't have a 2t in our answer, so we're going to want to get rid of that 2t. So there's 2 things that we're looking to do. We only want sines because we have cosec, and we also only want single t's. So naturally, we're going to use that cos double angle ID to get everything into sine and just individual t's. So exactly as I said, guys, we know we need cosec t, which is 1 over sine t. We want to get rid of that 2t, and we want to get rid of that cosine. We're going to use the double angle ID of cos 2t equals 1 minus 2 sine squared t, right? So all we're doing is plugging 1 minus 2 sine squared t into this dx dt equation. dy dx equation. So plugging in 1 minus 2 sine squared t, we have minus 2 sine t over 6 minus 1 minus 2 sine squared t. Minus 6 times 1 is minus 6. Minus 6 times minus 2 sine squared t. That's going to be plus 12 sine squared t. We can see on our denominator, 6 minus 6 is just 0. So we're left with minus 2 sine t over 12 sine squared t. Minus 2 over 12, that's minus 1 over 6. Then sine t over sine squared t, we're going to be left with, thank God again, 1 over sine t. And that is exactly cosec t. So we have minus a sixth multiplied by 1 over sine t. And that's exactly minus 1 over 6, or minus 1 over 6 cosec t. So our value for lambda that we had to find was minus 1 over 6. International paper, guys, international paper. In Edexcel, not all of the spec is the same, but many of the questions are similar, so definitely relevant for paper 2. Okay, moving on to part C, guys, and then I'll answer any questions. We're told that the point P with parameter t equals pi over 4 lies on C. So this is good, they already give us the corresponding value of t for P. The tangent to C at the point P cuts the y-axis at the point N, so nothing too tricky here. We have to find the exact y-coordinate of N, giving our answer in the simplest form, right? So there's a few things I'm already thinking, guys, for this question. We're going to need to know the coordinates of P in order to find that straight line that goes through P / our curve C. We're also going to need to know the gradient at our point P. So if we can find the gradient and the coordinates of P, we're going to be able to use that straight line equation, y minus y1 equals m times x minus x1, because we're going to know the coordinates of P, and we're also going to know the gradient, so all good. So let's do it, guys. We know t equals pi over 4 for our point P. So we can simply just plug in pi over 4 into our parametric equations to get the coordinates for P. So x is 6 times pi over 4 minus 3 times sine pi over 2. Put in your calculator, guys, I'm not going to waste your time. It's 3 over 2 pi minus, we know that sine of pi over 2 is just 1. Also 6 pi over 4 is just 3 over 2 pi. That's actually not too bad. 3 over 2 pi minus 3. Then we have 2 times cos pi over 4. Pi over 4 is that beautiful angle. Tan of pi over 4 is 1. And sine and both cos of pi over 4 is root 2 over 2. Root 2 over 2 times 2 is just root 2. So our y-coordinate is root 2. So we have our coordinate for P. We have that P equals 3 over 2 pi minus 3 and root 2. So we have our x1 and our y1. Now to find the gradient, well, we already have dy dx to be minus a sixth cosec t. Remember, guys, if you couldn't get it in the form of minus a sixth cosec t, you could have used your not simplified or not in the show that form of your answer to plug in t equals pi over 4. So don't stress too much if you didn't get k or this exact value, okay? So plugging in pi over 4, we have minus a sixth multiplied by 1 over sine pi over 4. Sine pi over 4 is 1 over root 2. So 1 over root 2. Denominator of a denominator goes up to the numerator. So that's minus a sixth multiplied by root 2. So we have minus root 2 over 6. So we have our gradient and we have x1 and we have y1. Plug it in that straight line equation. So exactly that, guys. We have our gradient to be minus root 2 over 6. Using the straight line equation, he says, using the straight line equation, y minus y1 equals m times x minus x1. Plug what we know, y1 is root 2, x1 is 3 over 2 pi minus 3, and our m is our gradient, minus root 2 over 6. And here's the thing, guys, you don't even need to expand this, because let's go back to what the question was asking us. The question was asking us the y-coordinate of n, okay, when we cut the y-axis. We cut the y-axis when x equals 0. Okay, so all we need to do, don't even expand it, plug in x equals 0, so we can then find y. We're going back down, plugging in x equals 0 into what we currently had. So exactly that, we want where we cut the y-axis, so we plug in, or set x equal to 0. So y minus root 2 equals minus root 2 over 6, 0 minus, then all in the brackets, 3 over 2 pi minus 3. So 0 take away 3 over 2 pi, it's minus 3 over 2 pi. Then 0 take away minus 3, minus 3, it's going to be plus 3. So we have that y equals minus root 2 over 6, minus 3 over 2 pi, plus 3, and we're going to be adding over that root 2 because we want y to be the subject of the formula. Simply expand this out, guys. Minus root 2 over 6 multiplied by minus 3 over 2 pi. That's going to be positive, minus minus, positive 3 over 12 root 2 pi. And then we have minus root 2 over 6 times by 3. That's going to be minus 3 over 6 plus root 2. We can simplify these fractions a bit. 3 over 12, that is just a quarter. And then minus 3 over 6, that is just minus a half. So we have y equals root 2 over 4 pi, take away root 2 over 2, plus root 2, minus root 2 over 2, plus root 2, that's just plus root 2 over 2. So we get our equation, or our value for y, to be y equals root 2 over 4 pi plus root 2 over 2. And that's exactly what we need to have y in the simplest form. And that's it, guys. I hope that makes sense, guys. Let me know if you have any questions. Couldn't you keep the x? And you could, you know what, you could do that. You could keep the x, but the reason I did it like this is just so we wouldn't have to do expansion. And because they wanted it in the simplest form, it made sense to not kind of make it all messy by rearranging. But you are right, we could have just done it like that. But I would say it probably helps just to set x equal to 0, and your first reaction when intercepting either of the axes will be to set the other thing equal to 0. Pax seems happy. Are we happy with these questions, guys? Because tomorrow I have harder questions tomorrow. I hope these questions are challenging enough. They seem pretty good. Definitely a lot of key skills that are going to be coming up in the exam. So either way, it's great practice. Once again, I'm going to make sure my stream hasn't blown up. Looks like we're all good. Okay, we are all good. Let me know if you guys have any questions. I'm going to leave up the next question on the screen if you guys want to have a go. Let me know, guys. Let me know. Cool, that makes sense. Would it not just be faster to use? Okay, guys. I used to be a y equals mx plus c advocate. Okay, I always use y equals mx plus c. But I found with these questions, if you always want to get it right, especially with that adrenaline in the exam, stress in the exam, I would always use this straight line equation. Would I need to factor out root 2 over 2? Root 2 over 2? No, no, no. I mean, if it was a show that question, they may ask you to get it in that form, but they would give you, even if you did factor it out, they would still give you the marks because it's a simplified form. But no, you wouldn't have to do that in this question. But there's a bit of leniency if they're being this vague, okay? Normally, it would either be a show that, or they would just accept any of these kind of answers. If you factored that out, it would be fine. 8 p.m. every day, 8 p.m. tomorrow, 8 p.m. today. Yeah, man, you're making pure look light, looking good learning stats. Guys, you're going to learn, I promise you guys, I will teach you all of stats in 3 days. I'm going to make everything make sense. You know, learning stats in school was never the best thing when I was doing it. I would definitely try and make things seem as easy as possible and make everything seem super logical. So when you're in that stats exam, you read these questions and you think, oh, it's a simple problem. Okay, I'll do my best to do that. I'm going to leave up this implicit differentiation and log question up for a second, guys. Give me a thumbs up if you want me to move on. Give me a thumbs up if you want me to move on, guys. I would say these questions are very useful. Let me know if these questions are too easy as well, because I want to put some challenging stuff in for tomorrow if you guys think this is too easy. But yeah, a bit of implicit differentiation. I clipped that. Oh, shite. Pax clipped it. No, no, it'll be easy, Pax. You're gonna learn all the stats. Trust me. It'll be fine. Yeah, stats is definitely the most useful part of maths, guys, in my opinion. I do think it's if you want to make some big money, I would go into stats. I say that making no big money, but we'll see. TJB is happy. TJB is happy. Have a go at this question, guys, while I waffle a bit. Just gonna have a sip of water, give it 30 seconds, and then I'm gonna be starting. Seeing loads of thumbs up. Okay, cool. Okay. I wouldn't say these questions are easy though, guys. There is definitely a lot of like key tricks and relating back to earlier parts of the question. Bit of trig identities. These are definitely not like not those first few questions. Some of these could be towards the end of the paper for sure. By the way, question 6 on the international paper is not the same as question 6 on our current paper. So don't think this is going to be the easiest thing. But I wouldn't say this is too bad. I wanted to include this question, guys, just because I think it's implicit differentiation hasn't come up. We haven't seen much logs. Music anytime is quite happy. Okay, okay, that's good, that's good. As long as you guys are getting that practicing these key skills that will come up in paper 2, that is what matters. All right, guys, let's attack this question. So we're told that curve C has equation y equals x to the power of sine x. We're told that x must be larger than 0 and y must be larger than 0. Okay? They tell us, find. This is quite friendly of them to be honest, guys. They may not do this in the exam. They say find by firstly taking natural logarithms an expression for dy dx in terms of x and y. So very friendly. They told us that we have to use the natural log. They may not tell that in the exam, so keep this in mind when you see a question like this, but we have to find dy dx, okay? Also, we see x to the power of sine x, we're thinking to ourselves, this is a bit suspicious. We're going to do what we can to make it look a bit different, but let's get onto that in a second. So taking the natural logs of both sides, we have natural of y equal the natural log of x to the power of sine x. I'm seeing this, I already know what I want to do. Rules of logarithms, guys. The reason we're doing this is because we hate to have x to the power of sine x. Okay, we want to do what we can to bring that sine x down to the front. Rules of logs: if we have x to the power of something, that power, guys, can come down to the front of our natural log. So rewriting this is ln y equals sine x times by ln x. So from here we can find dy dx, implicitly differentiating, guys. Remember, when we differentiate a function of y, we multiply it by dy dx, okay? So multiplying it by dy dx, ln y will differentiate to 1 over y. As we know, this has to be in your head right now. Darius is on it. Exactly that, Darius. So we have 1 over y dy dx. Let's differentiate sine x ln x. We have two functions of x multiplied by one another. We're going to have to use product rule, as Darius already said. So remember, guys, product rule, we leave, differentiate, then add, differentiate, leave. So leaving and differentiating, sine x we leave, natural log of x differentiates to 1 over x. Sine x multiplied by 1 over x is just sine x over x. And then we differentiate leave, sine x differentiates to cos x, and then we leave ln x. So we're going to have cos x ln x. Okay? From here, guys, we want to make dy dx the subject of the formula. So we're going to multiply through everything by y. So we're going to have that dy dx equals y times sine x over x plus y times cos x ln x. Now for this question, guys, if they wanted everything in terms of x, you would then just plug in that y equals x to the power of sine x for your y's. But they don't explicitly say that. All they say is they want it in terms of x and y. So we can actually leave it in this form, but you would have to be careful. If they wanted it just in terms of x, you'd have to make that final substitution in order to get that final mark. Definitely important, but in this case, you don't have to worry. So for part B, hence, we have to show that the x-coordinates of the stationary points of C are solutions to the equation tan x plus x ln x. Stationary points, guys. Stationary points are when dy dx equals 0. So remember, we're going to set dy dx equal to 0. We have this question and maybe one more, so however long it takes. So setting dy dx equal to 0, we already have dy dx equal to y sine x over x plus y cos x ln x. Now here's the very key thing, guys. Remember, they give you information for a reason, okay? They tell us that y is larger than 0. So when I see this, I'm thinking I would love to factor out y and divide by y, setting it all equal to 0. But normally we can't do that. Normally we can't just divide, because that could be a solution, y equals 0. But in this case, because we know that y is larger than 0, we can just divide by y. It's very friendly that they tell us that, but it's very key that we have to spot that. Because some people might then be starting to think, like, I can't just divide by y, but either way, we're focusing on what's inside that bracket. So factoring out y, you could still focus on sine x over x plus cos x ln x equal to 0, okay? As I said, divide both sides by y, we're left with sine x over x plus cos x ln x equals 0. Let's compare it to what we're trying to show. We're trying to show that tan x plus x ln x equals 0. Spot the difference, guys. Show that questions. They love a little bit of spot the difference. So spot the difference, guys. Sine x over x, we need tan x. We know that tan x is sine x over cos x. We also need x ln x. So we have to find a way to get x on this right-hand side. So first thing I'm thinking, let's multiply everything through by x. Multiplying everything through by x, we have sine x, getting rid of that denominator, plus cos x, x ln x. And because we have 0 on the right, it doesn't matter whether we're multiplying by x. Exactly that, Hassan, exactly that. We're then going to divide everything through by cos x. So we have sine x over cos x is tan x plus x ln x. That's exactly that, guys. We have tan x plus x ln x equal to 0. The tricky part here was realizing that we could just factor out the y, and the y wouldn't matter in our solutions when setting dy dx equal to 0. I think that's the key thing that may trip people up, because you can't just ignore the y. You have to consider the y when thinking about the solutions for our stationary points. Guys, let me know if you have any questions. I could either end it here or I could do one more question. Let me know if you guys want one more question or if I should end it here. It's a proof question, so it won't take too long. But definitely a good proof question, because proof by contradiction did not come up. So I would definitely say it's a key thing to know. And the proof by contradiction that I have, it'll either be today or tomorrow. It's definitely useful. So let me know if you guys want the proof or if I should end it here. If everything makes sense, all of that, how can we divide by cos x? So because everything is equal to 0, and we see we want tan x, we know that sin x over cos x equals tan x. So we just divide the whole thing through. Oh, everyone wants one more. Okay, cool. Okay, I'm seeing a lot of kind of like we've accidentally divided by y without realizing. In this case, you can divide by y. That's the thing. In this case, you can divide by y because it's larger than 0. The reason we divided by cos x is because in the show that question, we wanted tan x. Okay? So those are the two tricky things, guys. Yeah? We can divide by y because it's larger than 0. Normally, we're thinking that y equals 0 would have to be a solution when considering factoring out that y. Because if we set the whole thing equal to 0, would cos x equals 0 be a solution? Wouldn't it be, because we're dividing everything through by cos x, we have that tan x plus x ln x equals 0. All we're doing is manipulating what we currently have to make it look like in the show that. The key thing with these show that questions is look at what you're trying to get to and compare it what we currently have. And that's it. I hope that makes sense. I'll do one more, guys. I'll do one more. Remember all the questions asking, guys. We're not trying to find solutions. We're trying to show they satisfy the equation tan x plus x ln x equals 0. Okay? What would happen if it didn't give you y must be larger than 0? You'd have to consider the solution of y equals 0. And we know that y equals x to the power of sine x. So you have to consider that solution equal to 0. But the whole point is, because they only wanted tan x plus x ln x equals 0, it kind of implied that you could ignore that y. Yeah, if it showed that, don't ask questions. Like, to be honest, if you can get it, show that questions is just a game of spot the difference. Okay? Compare what you currently have to what you're trying to get to. Yeah? If we're not trying to find solutions, in general, guys, I'm actually going to quickly go back to the Monday and Tuesday revision session. In general, if we have a solution like this, where we're solving for x larger than 0, less than 360, and we have that sine x cos x equals 3 cos squared x, we cannot divide by cos x. Yeah? We cannot use cos x here. We would have to take away our sine x cos x from both sides, and then consider the two solutions of either cos x equals to 0 or 3 cos x minus sine x equals to 0. And then we would get all these solutions of cos x being 9270 and x equals 71 and tan x, sorry, by rearranging this. Tan x equals 3 equals x equals 71.6, 251.6. So I'm not really focusing on solutions here. The key thing is that we cannot divide by cos x in this equation. But because we had that show that question, it didn't really concern us particularly. But that is a good point, a good thing to think about in these questions. Don't think you can start dividing by cos x and all that. The key thing was that y was larger than 0, so we could divide by y. Okay? I will say again, guys, this document is available on my TikTok. Why can't we divide by cos x? Because well, you can divide by cos x, but you have to consider the solution of cos x equals 0. Okay? Because exactly here, guys, I would always recommend just to take away, if we have a question like this, you would just take away that sine x cos x from the right-hand side, and then solve this equal to 0. You factor out cos x, then you don't divide by cos x, because there will be a solution. Proof by contradiction is likely to come up. X has to be so surely cos x. So it's surely cos we have ln x. So I didn't really understand the question, but remember, guys, it is a show that question. We are just trying to show that stationary points are solutions to tan x plus x ln x equals 0. Okay? Don't get too stressed about this, guys. With the solving trig equations, we cannot divide by cos x. Because y was larger than 0, we could divide by y. And we were able to divide through by cos x and multiply through by x to make it look like what we had. Proof by contradiction is very likely to show up. So I'm going to do a proof by contradiction question, guys. I'm sure you've seen similar questions before. I'm sure you have. It's going to come up. Maybe not this specific one, but we do think proof by contradiction is very likely to come up. Hopefully it's one of those rational, irrational proofs. But we'll see. Alright guys, proof by contradiction that log base 3 of 5 is irrational. Proof by contradiction, we assume the opposite. We're going to assume that log base 3 of 5 is rational, okay? I see a lot of confusion about the rational, irrational numbers as well. So let's just make it very, very clear what a rational number is. If I have to, I'll even put a chat GPT thing on my story just to settle the debate, okay? Because I had a few people asking me questions. So remember, guys, we're going to assume. I have to say, guys, if these are helpful and the videos are helpful, please subscribe to the YouTube. I would be eternally grateful. Hassan is already saying the right thing. We're going to assume that it's rational. Rational, guys. If we have a rational number, we can express it as a ratio of integers. Normally, people say a simplified ratio of integers. In this question, it doesn't matter. When proving root 2 is rational, it does matter. In this question, it doesn't matter. If you want, you can always say it's a simplified ratio of integers, but the key thing, it can be expressed as a ratio of integers. Okay? So log base 3 of 5 equals a over b. What is a log telling us? A log is giving us the answer of 3 to the power of something, this a over b, equals 5. So we know that 3 to the power of a over b equals 5. What we can do from here, guys, is we can put each of our side, left and right, to the power of b. So we have 3 to the power of a equals 5 to the power of b. Because remember, guys, when we have a power to a power, we just multiply the indices. So a over b times by b is just a, and then 5 to the b is just b. Okay? So we have 5 to the power of b equals 3 to the a. This is all we really have to do in this question, guys. Once you're at this point, all you have to say is this cannot be true. That's a equals b equals 0. Of course, if they both equal 0, then the left-hand side and the right-hand side can both be equal to 1. If not, we can say these are distinct prime numbers, so their powers can't be equal to each other. In this question, you can't use the odd-even argument. Sometimes if you have 2 to the power of a, and for example 7 to the power of b, you can say one will always be even, one will always be odd. You can't say that here. You have to say they're distinct prime numbers, so the powers cannot be equal to one another. Think about that factor tree that you do in GCSE, that kind of explains it. So therefore, we contradict our assumption. So log base 3 of 5 is irrational. 3 to the a can't be 5 to the b, exactly that, exactly that. It's a very short proof, guys, but it's one of those you just need to remember. One of those you need to remember, to be honest. I could actually pull up, I might have to go to Westy's workshop, guys. I'm going to go to Westy's workshop right now. I'd recommend this website. Oh, guys, it's refusing to connect. This website is always on and off, guys, but it has every proof. Ah, here we go. All the key proofs that you guys need to know. If you want to just look through the proofs by contradiction, I would definitely recommend this website. Can I show you a vinyl collection? Just some little Sims, Dave, nothing crazy. But yeah, this website I definitely recommend, guys. Westy's Workshop, A2 Pure Proofs. If you feel not very confident about any of these contradictions, almost any contradiction question that can come up, do you have to say distinct primes or say distinct primes? Because say distinct primes. I think actually, you could say primes by itself, but I've always seen people write distinct primes, so it will definitely help to guarantee marks. If we're asking these questions and you're unsure, just write distincts to guarantee the marks. But I'm pretty sure you can just write primes because it's the same idea of that GCSE factor tree. The same way that 2 to the power of something can't be equal to 7 to the power of something because you have these prime numbers as you did in GCSE. It's a good way to think of it. But guys, I'm not going to go through all these questions, but I would definitely recommend looking at this if you're not very sure with proof by contradiction. There is one proof that I do want to just talk about just for a minute. To go, that has all the solutions, guys, all the solutions on here. There was one proof, and not all of these proofs are from past papers. A lot of them are just, I think, like practice questions or mock questions or international. So I definitely recommend this, guys. But of course, you have your classics, proving root 2 is irrational, proof by contradiction. There's a lot of contradiction here. So if you want to be very comfortable for contradiction, even on the morning before, have a peek at this. It might not come up. I can't guarantee it's going to come up, but it's very likely. There is one I wanted to address, guys. Okay, guys, I actually made a video on this question. I don't think I addressed this question properly. I think there was one key answer that I didn't mention. It's a very good proof that hasn't come up in a past paper. So if a proof by contradiction comes up, and it's one that not many people know, I would say it's going to be a proof like this. I do not play Roblox. So here's the solution, guys. It's one of those ones that you have to add 1 at the end. Let me just make sure everything. Same thing as always. Assume the opposite is true. Assume we have a list of a finite number of prime numbers. Okay? I'm going to go through this right now. I'll go through it right now. So proof by contradiction that there are infinitely many prime numbers. Assume the opposite. Okay? We're going to assume there are a finite number of prime numbers. if there are a finite number of prime numbers, we can just list out all of the prime numbers. Okay, so that's what we're saying. We have prime 1, prime 2, all the way up to the nth prime number, a finite number, so the nth prime number. Okay, we're going to consider a new number. Consider a new number that is 1 greater than the product of all the existing prime numbers. Okay, so we're going to call it n. N is all of our prime numbers multiplied together plus 1. So here's the bit that I actually said wrong in my video, guys. In my video, I said, because, let's just read through it, guys, and then I'll give a little explanation. So we have to understand that the implication of this new number is that the division by any of the existing prime numbers in our list will leave a remainder of 1. So none of the existing prime numbers is a factor of n. This means that n will only be divisible by 1 and itself, because all of our listed primes aren't able to divide this without leaving a remainder of 1. Okay? So then this is the conclusion. This is the problem that I did in my video. Yeah? I just said this means that n will not be prime. Yeah? But what we have to say is this means that either n is prime. Oh, sorry, this means that n will be prime. So we have to conclude that either n is prime or n has a prime factor that is not currently listed. I didn't say the currently listed thing. I just said we have to conclude that n must be a prime number. But these are the two things you have to say. Okay? So let's just think about it. Because we're adding 1, if we divided by any of the prime numbers that we listed out, we'd have a remainder of 1. Okay? But the other thing that could have possibly been is there could have been a prime number that we hadn't listed within our list, yeah, that would have been before our value of n, within the list of prime numbers that we would have been able to divide n by. Okay? So those are the two things. You say either n is prime or n has a prime factor that hasn't currently been listed. Either way, sorry, that means there's going to be another prime number. So we've proved that there is not a finite number of prime numbers. There's going to be an infinite number of prime numbers. This is a good proof, guys. One of those ones, if you know it, other people won't get the marks. It might not come up, but it might come up. Could get you into Oxford, Cambridge, or Imperial. And then you say, either way, we have a contradiction. There's not going to be a finite number. There's going to be an infinite number. Because these are generic primes, P1 to Pn, we're not naming any numbers. And because we're just adding 1 every time, it's generic. We've generalized it. So we have there must be an infinite number of prime numbers. You're the guy, can you do a speech? Speech tomorrow, guys. Speech tomorrow before the exam. I said it before, you guys don't really need speeches. Like A-level math students are a different level. You guys have the motivation, determination. I couldn't imagine people who just do econ and business without any maths showing up to these live streams. No hate on econ and business, but you guys are a different level. I hope that makes sense, guys. I'm not going to keep the stream going too long if people want to watch it back. We've been going for just over an hour, maybe hour 10, hour 15. I hope that's all good, guys. Let me know if you guys have any questions about any of these proofs. I would definitely recommend this website, Westy's Workshop. I'd also recommend, I actually did quite a lot of the predicted topics for paper 2 in my previous live streams before. So if you want to look at the documents in my bio, would also be helpful. Econ, maths, history. I'll rate that, I'll rate the history. History's interesting. It's one of those things that you kind of regret not doing further. I definitely recommend. Actually, those A levels are quite good for like an econ and history degree, to be fair. Maths, geography, media. I rate geography. Actually, one of my best mates does media, to be fair. Year below. And gap year. Let me see if that all makes sense. Looks like we're all good on the live stream. You do maths. If you do maths, everything's fine. Everyone's listening to A levels now. Biochem maths is on top. I didn't even do biochem maths, but I do think it's elite. I do recommend MADAS, but with MADAS you have to be very careful to only be doing questions that are relevant, okay? Guys, I'm just going to say for tomorrow, we have parametric integration, a bit of first principles recap, got to know it. I have a tricky one though, guys. It's not just your classic x squared. Something a little bit, maybe you haven't seen it before, maybe you have. Inverse trig doesn't always come up, not likely to come up, but I did want to address this, and it does have some of these like essential skills that you're going to be using in most of the questions. Got a trig modeling question. Trig modeling is going to come up. And a geometric series. This is quite a scary geometric series question, but I'm going to make it look easy tomorrow, okay? I might do one more question tomorrow, but we're all done for today, guys. I think we're all good. I wish you guys the best of luck in your revision, and I hope I see most of you tomorrow.